Hello everyone, welcome to COMP125. In this video we are going to talk about different control flows and we are going to actually focus on conditional structures. Okay, in the previous video we have seen many different algorithms, problems that we have solved, and the algorithms that we actually written for all of those problems were a sequence of statements that all of them will be executed. You started at the beginning and execute all of the statements until you are done. For example, remember this was one of the examples that we have actually covered that calculates the amount of space that an object will actually follow, the amount of distance that an object will pass if you actually just drop it in a free fall. But the thing is, all of these examples were very simple examples, and in fact, if you are solving more sophisticated problems and you are writing more complicated algorithms, these type of statements, just only writing all of the statements in sequential way is not going to be enough for us. So here I need to actually define a term that we call it a control structure. A control structure, when we're writing an algorithm or when you are writing a program for a computer to execute, is actually a structure that allows the computer to control which statement is the next one to be executed. For example, here the control structure is sequential. The algorithm knows that it should just sequentially execute all of these statements. Okay? But the thing is, we need different types of control structure. Just only the sequential structure is not going to be enough for us to write all type of programs. In fact, there are three different type of control structures. Sequential control, that we have already seen many examples of this one, that you just write down a couple of statements, simple statements that basically most of them are just assigning something to some variable or printing something in the output or just getting something from the input, right? So this is going to be a sequential control. The other two, the first one is called conditional structure, and the last one is called iterative. Conditional, or sometimes we call it selection or branching or decision-making structures, control structures, allows us to select between two, and sometimes actually just if you are writing in a high-level programming language, it might allows you to choose between more than two alternatives. Okay, just a simple example of a conditional control structure is that based on some specific condition, you either actually, for example, every day when I'm actually getting out of home, I will check the weather. If the weather is rainy, I will take my umbrella. If not, I would not take my umbrella, right? So just this action, that taking the umbrella or not, will depend on the condition of the weather. This is something that you check it every day. Okay, you don't always just take the umbrella or always don't take the umbrella. So there are two, this action, that taking the umbrella, will depend on the value of the some condition. And the last one is iterative or looping or repeating, that allows us to repeat a bunch of statements, one or more than one. Something like iterative structures is, let me actually give you an example. For example, assume you are wanting to eat, a bowl of soup or a bowl of salad, and you are just at each, you will take 1 spoon of your soup, eat it, and then you actually repeat this step again and again and again until when? Until your bowl is empty, right? So until some specific condition became true or became false, you will keep repeating a set of instructions. So this is going to be iterative or looping that I'm going to cover in another video. So let's focus on the conditional structure. Actually, before I will leave this slide, I'm going to give you this theorem that the Boehm-Jacobian theorem is a very famous theorem in computer science, and that is saying that I'm sorry for the noise, any computer program that you write, any problem which we can solve it, we can write it down using a computer program that has all of these 3 control structures: sequential, conditional, and iterative. And you don't need any other type of control structure to write the program. So if anything, any problem, it doesn't matter how sophisticated, how complicated is the problem, you can solve it if you have access to some programming language that allows you to write down your program in terms of using these different 3 structures. Okay, I'm going to just let this ambulance pass. Okay, conditional statements. Okay, I'm going to focus on conditional statements here. So as I mentioned before, conditional statements allows us to choose between 2 different alternatives based on the value of some specific condition. That condition is going to be a Boolean condition. Either this is going to be true or false. Okay, so based on that, if it is true, you will do some specific action. If it is false, you will do another action. If you want to write down the pseudocode, this is the syntax that we follow in the pseudocode. That, for example, we are going to write down some condition. As I said before, that condition is going to be a Boolean condition. Or it is going to be a true-false condition. If that condition is true, it's just like you go and do a block of statements. It can be 1 or more than 1, okay? And then if it is not, if the condition is false, you will execute this one. So if the condition is true, this condition will be executed. If the condition is false, this part will be executed, but not both of them. So you can see that this is not going to be a sequential structure. Again, here is an example. For example, just assume that every day you go for you wanted to either go for a walk or go for ice skating on a lake close to your home. So every day you check if in the winter, if the ice on the surface of the lake is thick, you can go for ice skating on the lake. Otherwise, you will go a walk around the lake. Okay, so based on this condition, which is going to be a Boolean condition, either the ice is thick or not. If it is thick, you will go for ice skating. If it is not thick enough, you will go for a walk. Okay, here let me actually show you an image that I'm going to basically come back to it later and talk more about that. Generally, this is called the flow chart. This is the graphical, the visual way that shows you how the conditional statement actually works. As you can see, I have written that Boolean condition here inside this diamond. You can think about whatever you write as your program. Just draw a flow chart for that. This flow chart shows that how the computer basically execute the program. Just assume that the computer reaches to this point, okay, check the Boolean condition. Based on the value of that, either if it is true or false, if it is true, the computer actually is just like it follows this path and go and execute all of these statements that, for example, execute the statement T1, then T2, T3, every statements that you have written here, and then after that it actually goes and execute this statement. If it is false, if the Boolean condition is false, the result of this evaluating this condition is false, the computer will follow this path and execute all of these actual statements, F1, F2, F3, and then at the end, for example, it actually reaches to the statement S. So you can see that this statement S is outside of the Boolean condition. If I go back to this, this pseudocode thing, let me just clean up a little bit. Okay, based on the value of the Boolean condition, you either, although actually when I'm writing it, it is in a form of a, because this is, this is the way that we write. I have actually write all of these 4 lines sequentially, but you should read it in this way, that the computer checks the condition. If it is true, it will execute this block of a statement, all of these statements here, and when it is done with executing this block, it will go to whatever you write after the else part. If it is false, if the condition is false, the computer will ignore this part completely. Computer doesn't see this part, will not execute this part. It just jumps to the else part, execute everything that you have here, and then after that it actually goes and execute whatever you write here. So this flowchart here just basically gives you this idea that how the computer will choose between 2 different branches. Either it actually follow this path or this path based on the value of the Boolean condition. Let me show you an example to make it more clear that what we are actually talking about here. Assume that we are writing a program for a company to actually calculate the wage of their employees. Okay, the weekly wage of the employees. The thing is, there are 2 different formula to calculate the wages. Some of the employees are going to work regular time, just assume that up to 40 hours per week, and there is a specific rate to pay the wage of those employees. But some of the employees are going to work overtime. So for those who are working overtime, for the amount of hours, how many hours that they are working overtime, they will be paid 50% more. Okay? So there are going to be 2 different formulas to calculate the wages for the employees based on how many hours they have worked. If an employee worked 40 hours or less, the salary will be calculated based on some specific rate multiplied by how many hours that employee actually worked that week. Otherwise, if the employee actually worked overtime, the employee will get paid that specific rate for the first 40 hours, and for the time that overtime actually they are going to be paid 50% more. So it's just like the formula for that is going to be 1.5 to make it 50% more, multiplied by rate, multiplied by the amount of hours that all the overtime that they worked. Okay, so how can I write an algorithm for the company? So just assume that your program is you each time enter the amount of hours that each employee have worked for example, the last week, and you entered to the program, and the program just returned the wage for that specific employee. So the value of the wage is going to be the output. Let me actually show you some sample algorithm that I can write just based on whatever we know from the previous video. Okay, just assume that I have written a specific this algorithm, this pseudocode. Set a variable, define a variable rate, set it to 10.45. I'm not quite sure that was going to be the minimum wage no, but it was 10.45 at some point when I actually first prepared this set of lectures. But anyway, sorry if it is not correct. I'm sure that it's going to be more no. But anyway, just assume that this is going to be the rate that's going to be paid is 10.45, $10.45 for every hour. Okay, so set rate to this value and then get the value of hours from the input. So now I have rate and I have hours. So calculate salary or set salary to, this is the formula for calculating the salary for overtime, and this is the formula. This is another actually a statement that calculate the salary to be the other actually formula. Now you can actually see that the program, the pseudocode that I have written here is not using the conditional statement. I just use the sequential statement. If you write down a program corresponding this pseudocode to the computer, the way that it actually executes this one is that it executes this line, then this line, then this line, then this line, then this line. Just like, all the previous programs that we have seen. So now let's actually just try this pseudocode over some examples and see that what would happen. Just assume that you have written the program and you are taking the input from the user each time that the user enters, for example, 34. How many hours this employee has been working, it's 34. So what would happen if you enter 34 as hours? Salary will first be calculated using this formula, but this is not going to be the correct actual salary, right? But then it will be actually executed using this line. Whatever you have executed here will be gone because you are actually writing a new value inside that, which is going to be 34 multiplied by 10.45. And this is going to be the value of the salary and it will be returned. Okay, and this is correct, right? This program is going to work properly for 34. But does it going to work properly for if the value of hours that the user entered, if it is 60, what will be the output? Is the output going to be correct? You can see that although you set the rate to 10.45 and you get the value of hours, which is going to be 60, right? And then the value of salary will be calculated. So if I'm going to actually follow all of those steps, it's going to be something like this: rate, hours, and salary. So rate is 10.45, hours is just given by the user is going to be 60. And then here in this line, salary will be calculated as rate multiplied by 40 plus 1.5 multiplied by rate multiplied by hours minus 40, which is going to be 20. So you can see that this value, I can calculate, it's going to be too much math for me to do here. But anyway, this value is going to be the correct value for salary, right? But you actually all of a sudden in the next line, you will rewrite a wrong answer inside the salary. This formula is not the correct formula to calculate the salary if the value of hours is for 60, right? Because this employee has been working 20 hours overtime. So you are going to pay more for that actually overtime. You are going to pay 50% more for that, the overtime. Okay, so, but the value that you are going to print for salary is going to be wrong. So the branching or the conditional structure operations are going to help us here. Instead of just writing both of these two statements, and the computer will execute both of them actually, for some of the values this algorithm is going to give you the wrong answer. Instead of writing the program in this way, I can use the conditional statements and write down an if-else statement and make my program correct. Now you can see that I have added this if statement and also actually the else part, and in this way I am writing a conditional a Boolean condition actually here. This Boolean condition is going to have true or false value. You can see that I'm checking the value of hours, comparing it by 40. If the value of hours is greater than 40, the value of salary will be actually set to this formula. Using this formula, it will be executed using this formula. If the value of this Boolean condition is false, basically means that then the amount of hours, the value of hours is going to be less than or equal to 40. So in that case, if it is less than or equal to 40, so you are going to the else part, and this block, which is going to be just one statement, will be executed. So in this way, it doesn't matter what is going to be the hour. If it is more than 40 or it is less than 40, the value of salary will be executed using the correct formula, either using actually this statement or this statement, but the other one will be actually just completely ignored by the computer. If the Boolean condition is true, this part will be executed. If the Boolean condition is false, this part will be executed, and the other one will be completely ignored. So now actually you can again try to trace this pseudocode, to simulate this pseudocode with different values like 60 and 34. For example, if the value of hours that you entered is going to be 60, so you can actually, if you trace this algorithm, you will see that 60 is more than 40, right? So this is going to be true. Which statement will be executed? This one. So salary will be executed using this formula. If the value of hours that you entered is going to be 34, so 34 greater than 40 is going to be false because it is not greater than 40, right? So this statement will be executed, and salary will be equal to rate multiplied by hours. This is going to be a correct formula, and at the end, whatever is the salary will be executed. So you can see that either if it is this one is executed or this one, after you are done with this, the whole if-else statement part, this line will be executed. Okay, now let me actually talk about the flowcharts a little bit. This is something that your textbook hasn't covered. It just shows you the, this figure 2.4, but they did not really elaborate on the flowcharts. But I think it's gonna be actually something useful for you to be able to draw some flowcharts for your algorithms. It actually helps you to understand that how really actually computer is going to execute the program. So let me just define a couple of notations here. When we are drawing a flowchart, if you are not familiar with a flowchart is going to be some graphical ways to just write down your algorithm, your pseudocode. We are going to have a couple of components here. The oval is used to show the start and end of your program. The diamonds are going to used to show the decision. For example, you are checking a Boolean condition, you are writing it inside the a diamond. All of the statements, the processing that you do, for example, set hours to set salary to rate multiplied by hours. These processing statements will be written in the rectangle shape, and when you are actually getting something from the input or printing something in the output, it will be actually written inside the parallelogram. And all of these shapes will be connected with an arrow. So basically an arrow shows you the flow of your algorithm, how the computer actually follow all the instructions and execute them. This is an example of showing an if-then condition. So you can see that here. Just assume that because this is not a real pseudocode, I haven't actually written anything for this one, but this is just an example of writing a flowchart. You can see that I'm showing the start and ending of the flowchart using the oval. So when you are actually you wanted to see that where to start, you should start from this oval that I've actually specifically specified with the word start. And then you get all of your inputs. For example, you are getting hour, you will write it as get hours, for example, something like that. All of the inputs that you are getting from the user. And this is going to be those Boolean conditions that you write it in this decision thing. And if the answer is yes, if the answer is true or yes, you will actually go this way and you do all of the processes that you want. And then, for example, printing something in the output here, and then you finish. If the condition is false, you see that this is not a if-then else statement. This is if-then condition. So basically, it's just like if the condition is not true, you don't like to do anything. You wanted to just terminate. So you can see that if the answer to this Boolean condition or decision is false, you just directly execute, terminates the program. So it just directly go to the stop part. If you have a decision that has an else part, it will be actually showed like this. That you have a Boolean condition, you write your Boolean condition here. If the answer is true or yes, you will follow this path. If the answer is no, you will follow this path. So it's just like you are writing and like if some condition, then, so this is going to be that block of process A. This is going to be a block of a statement. And then you write an else part, you put process B, okay? And at the end, you, for example, print something in the output. So it's just like something like this, that if you have an if-else part, like the example that I showed you. So either this statement or this statement will be executed. Either the program will follow this path or it follows this path. Okay, so let me actually just talk about that Boolean expression for a little bit, because this is something important. What you can write down as a decision, as a Boolean expression in your conditional statement, it should be a Boolean expression. Okay, so it means that when you evaluate that expression, the result should be true or false. Computer just actually can answer based on that. It cannot answer based on, okay, one the result of your expression cannot be, for example, an integer number. The result should be either true or false, just only two possible answer for that, true or false. Usually these conditional expressions that we write, these Boolean expressions that we write, they are going to be some comparisons. You are doing some comparisons over some value. For example, comparing hours with 40. Either the value of hours is greater than this comparison, is just, for example, greater than. Either hours, whatever is the value of hours, it is going to be either greater than 40 or not, right? So if hours is 35, this statement, this Boolean expression is going to be false. You excuse my handwriting. If the value of hours is 15, this Boolean expression is going to be false. If the value of hours is 40, this Boolean expression is going to be false, right? Be careful, this is written as greater than 40. If the value of hours is 51, this Boolean expression is going to be true. If the value of hours is 62, this Boolean expression is going to be true. If it is 41, it is going to be true. So this is a valid Boolean expressions that based on the value of hours, because the hours is going to be a number, it is going to be either greater than 40 or not. So the result is going to be true or false. So most of the conditions that we write, especially in the examples that we covered in this course, they are going to be comparisons between some values, some numbers, or for example, some strings, if the variable that you're working on is going to be a string. So all the comparison operators that we are covering are going to be, for example, equal, not equal, less than, greater than, or less than or equal, greater than or equal. So we have all of these 6 different, kind of operators. In some of the examples that you might have seen, basically in computer science, instead of 1 equal, in this actually in your textbook you always see 1 equal, but if you see somewhere double equal, specifically in terms of computer science, double equal also is actually basically means equal. In all programming languages that we have, instead of using a single equal, basically we use double equal to compare two values. And instead of not, this is a mathematical way to represent not equal. In computer science, we usually actually show it in this way. So if you see these notations, don't be confused. This basically means equal. This is going to be not equal. Less than or equal usually will be represented this way if you are writing some source code. Greater than or equal will be actually represented this way. And then actually the rest of this less than or less than, both of them are going to be the same. Okay, let me actually show you some example here. For example, if I write down a couple of statements, just assume that I have two variables, x and y. X has been set to 5 and y has been set to 7. Okay, all of these Boolean expressions that I have written, they are going to be Boolean expressions, and I have actually written the value of them in front of it. So if you write x less than y, the result of this Boolean expression is going to be true because x is 5 and y is 7. So yes, x is less than y, so the answer is true. X is greater than y is going to be false because x is 5, y is 7, it is not greater than y. They are equal or not, it is the answer, the result of this comparison is going to be false because they are not equal. If x is less than or equal to y, this is going to be true because 5 is less than or equal to 7. 5 is not greater than or equal to 7, so this one is going to be false. And 5 is not equal to 7, right? And so this one is true. Remember, this one was supposed to be mean not equal. Okay, and this one is supposed to mean equal. As I said, in computer science, in almost all programming languages, instead of a single equal in math, we write it as double equal. In your textbook, it's just always used as single equal, but I just wanted to introduce this double equal here to you as well. Okay, let me actually show you some fun questions here. Assume that we have written an algorithm, a simple algorithm like this, and just assume that the user enters 10. So what will be the output of this algorithm if the user enters 10 for x? Okay, so if the value of x is 10, you have an if statement here, right? It is comparing x to 100. X is 10, 10 greater than 100 is not, so this is going to be false. So you can see that this statement will not be executed. So it's just like the computer will not see this at all. Basically, the computer will see it, but it's not going to execute it, right? So it just directly jumps and print x. What is the value of x? The value of x that you entered is 10. So the correct answer is going to be 10. So what would be the output if the user entered 120? So if you pass 120 instead of x, so the value of x is going to be 120. 120 greater than 100. Yes, this is true. This conditional, this Boolean expression is going to be true. So the computer will execute this line. So x will be set to x divided by 100, which is going to be 1.20. Sorry, I think I made it wrong. 120 divided by 100. Yes, it's going to be 1.20. Okay, and then you print x. So the correct value is going to be 1.2. I have changed the algorithm a little bit. Now tell me that what will be the output if the user entered 120. So if this algorithm says to get the value for x, just assume that you give 120. So 120 is greater than 100, right? So it is true, this statement. So this statement will be executed. X will be equal to x divided by 100, which is going to be 1.20, right? But then this statement will be executed. You see that this statement is out of the if condition and it's not inside an else or anything. So after that line, this line will be executed. No, the new value of x will be 10. So if remember that table that I told you, you can actually draw that table as well. The first value of x was going to be 120. Then in this line, the value of x will be changed to 1.2. And then in this line, the value of x will be changed to 10. And so at the end, when you are printing the value of x, the final value of x is going to be 10. So this is going to be the correct answer. Okay, so let's see another example. Assume that we want to write an algorithm that get two numbers from the user. Let's call them x and y. So these are going to be the name of the variables, and compare them. And based on their values, print the appropriate message. So either print that the first number is greater, the second number is greater, or they are equal. If you enter two numbers, there are three possibilities, right? Either the first one is greater, or the second one is greater, or they are equal. So we have three possibilities. I just wanted to actually show you that How? By using a couple of conditional statements, I can solve it, because here I have three alternatives. One conditional statement is not possible to actually answer, helps us to answer and write the correct algorithm here. But I can use a couple of, a combination of the if conditional statements to write the correct answer. This is one example, that one answer that I have actually covered here. Get a value. First, I need to get the values from the user. So get a value for x, get a value for y. Then if x is greater than y, this is going to actually cover the first possibility, right? If x is greater than y, then print this message. The first number is greater. But if it is not, so don't print that message, right? So I have just written it as, in the else part, do nothing. I have written another condition that checks that x is less than y. If x is less than y, x is the first number and y is the second number. So in this case, the second number is greater. So if it is true, print the second number is greater. If not, do nothing. And I have written another condition to check the last possibility. If x is greater than, x is equal to y, you see that I have actually used double equal. You can just use single equal as well. Doesn't really matter in this course. This is not programming course, so just the single equal is enough. And in your textbook, it's usually actually just written single y. If x is equal to y, then you print both are equal, and otherwise you do nothing. Okay, you can see that I have written all of these as a if-else statements. Because I have written them as in the else part, I don't want the computer to do anything. I can simply just remove the else parts, right? And simplify the algorithm and write it in this way. If x is greater than y, print this. If x is less than y, print this. If x is equal to y, print this. And you can see that because x and y, both of them are going to be two numbers, only one of these conditions are going to be true. So either x is greater than y, so this one will be printed, or x is less than 1, this one will be printed, or if they are equal, so this one will be printed.